Welcome back for video 3 in the chemistry naming series. Today we're going to be also talking about ionic naming, just like the last video. And what I wanted to bring your attention to is this video over here. So you see, what can happen is if you have a metal, which again makes it ionic, that again will mean a metal plus a nonmetal. And to just really hit this point home, no prefixes over here at all, ever, no. Just to make sure that I hit that point at home. So what will happen is if your metal is not a transition metal, that'll be in the next video, two things are going to happen. You're either going to have two elements, which we talked about in the last video, or you're going to have more than two elements. These are going to be involving the polyatomic ions. So really, the rules are the same, but I want to draw your attention to the polyatomic ion piece because that piece is a little bit different. And please note, we are not changing our ending to "ide." I want to go really quickly back to what we talked about that first video. When we have this, right, these are bigger than these two. Poly is another word for many. Atomic is atoms, and ions mean charge. So all that a polyatomic ion is, it's a bigger ion. That's really all it is. So these have very set names. You don't have to change these at all. The smaller ones are the ide, not these. And to just draw your attention to, for me and my students, the back of the periodic table, you can see that there are a lot of ites and eights like that you had. Yes, hydroxide has an I. Yes, cyanide has an ide. Okay, but those are specific names to these chemicals. And I do want to draw your attention today. There is one positive one. If you notice, these are all -3. These are all -2. This huge list is -1, but there is one positive one, and I'll make sure to do an example of that as well. So, honestly, the rules are the exact same because it's all ionic naming. So really, what we just have to do is acknowledge that we need to look at the polyatomic ions, and again, acknowledge that there's no prefixes. And if we look at this, I don't see any prefixes, there's no ides, and we should be good to go. So how do we do this? What I do is same thing. I'm going to simply start putting the charges of what I know on the periodic table. +2, +2, +2, +1, +3. Well, ammonium is not aluminum. This is a new one, and that is not on the periodic table. It's right here. So ammonium is a +1. So actually, if you look, we know the charge for all these too. So all I would recommend doing is just look these up on the back. And that's really cool. And again, for Mr. Nenya students, they might be on the back of yours, they might be on a separate list. Totally cool, totally fine. I also know that they might be on the College Board cheat sheet. Regardless, these are all things that you have access to. And those charges are for nitrite -1, acetate -1, phosphate -3, permanganate -1, chromate -2, and sulfate -2. If you double checked me, those literally all come from here, just to save you some time. So what do we do? Well, make sure that they work, okay? So with this one, it'll be Mg for magnesium, nitrite is NO2, and if we switch those charges, that 2 needs to go here. But let's hold up for a second. What you should notice is this looks weird. if I bring this 2 over to nitrite, and nitrite already has a 2, well, that looks like 22. So what I recommend with all of these, okay, any single time you are on the back, use parentheses to keep them separated. This will make your life easier because now you can tell, okay, I have 2 of these NO2s. So this is magnesium with 2 of these bigger ions. This 2 distributes just like in math class. So any single time you see a polyatomic ion, and this doesn't happen every time, what I highly, highly recommend, put them in parentheses. You won't need it every time. You won't, okay? The next one we do, you won't. But I do want to show you that it is useful information. So, for example, this one we don't need it. Sodium is Na, and permanganate is MnO4, and it's a +1 with a -1, so you're good, but you are more than welcome to add the parenthesis. So this is correct. So put all these in parentheses. Even if you don't need to, you'll be safe every single time. To do one more, I want to do that ammonium for you. Ammonium is NH4. That, again, is on the back of your periodic table. It's the only positive one. Sulfate is SO4. Again, that's also on the back. That is allowed. That is totally fine. And if we do the crisscross thing, between these two, well, there needs to be 2 +1s to balance out with a -2. So our 2 will end up over here this time. Again, I would highly recommend doing the parentheses. This will work every time. It's the same thing. Only difference, look on the back. Over here, what we'll end up doing is actually very similar. But this one, I think you'll find this one really, really, really easy. Guess what? Ca is calcium. OH is hydroxide. So the name of this is calcium hydroxide. This is lithium. Cr2O7 is huge, but that is dichromate. Again, that is on the back of the periodic table. And you'll notice, I'm just saying what they are. That's all you need to do. Just tell me what you're looking at. That's lithium, that's dichromate. No prefixes, just say what it is. This is aluminum. And NO2 is nitrite. Again, I do with the nitrite, I do recommend be very careful with these. These are very close. These are very close. These are very close. So just acknowledge that. And really, that's how you do all of the polyatomic ion ones. Crisscross like you have been doing, name it like you have been doing.